Hello everyone and welcome to Mechanics and Dynamics lectures. In this lecture we solve a problem related to the motion of a projectile that is launched with certain initial velocity. We will show that the projectile's trajectory is a parabolic function and we will derive the equations describing the motion of the projectile. This problem is important since in a more complex form it appears in a large number of physics, engineering, and aerospace applications. But before I start with explanations, I need to mention the following. Please feel free to ask questions and give your feedback. You can do that by leaving a comment in the comment section below this video. Also, I have to mention that it took me a significant amount of time, energy, and planning to create this completely free video tutorial, as well as more than 300 free video tutorials that you can find on my YouTube page. And consequently, I kindly ask you to press the like and subscribe buttons. Thanks a lot! Okay, let's start. Here is the problem formulation. A projectile is launched with the initial velocity v0. Here is the initial velocity and here is the projectile. The initial velocity is described by the x projection, denoted by v0x, and the y projection, denoted by v0y. We assume that the air resistance can be neglected. We need to determine a. X and y components of the velocity vector as the function of time. B. Horizontal and vertical traveled distances as functions of time. That is, we need to determine x as a function of time and y as the function of time. C. Shape and mathematical function describing the projectile's trajectory. D. Horizontal distance that the projectile traveled until it reached the target. That is, we need to determine this distance and the shape of this function. To solve this problem, we need to start from Newton's second law. First, we need to determine the forces acting on this particle. That is, the forces acting on our projectile. Obviously, we only have a single force. We have the gravity force, and this force is equal to m times g. That is, the mass of the projectile times the g acceleration. From the Newton's second law, we obtain the following equation. Mass times the acceleration of the projectile is equal to the sum of all the forces acting on the projectile. In our case, we only have mg. Note over here that this is a vector equation, and consequently I don't have a plus or minus sign. I will obtain a plus or a minus sign once I project this equation onto the x and y axis. To project this equation onto the x and y axis, we need to introduce the unit vectors. This is the I unit vector of the x-axis and this is the j unit vector of the y-axis. To obtain the x projection, we need to scalarly multiply this equation with I. Let's do that. As the result, we obtain m ax is equal to, let's see, what is the x projection of mg? It's equal to 0. And from this equation, we obtain that ax is actually equal to 0. Ax is the second derivative of the position x of our projectile. Let's catch this position. Here it is. This is the x position of the projectile. And this is the y position of the projectile. From this equation, we obtain that the second derivative of x is equal to 0. That is, d dt x dot should be equal to 0. From this equation, we obtain that x dot should be equal to some constant. And let's denote this constant by C1. Let us determine this constant. We can determine this constant from the initial condition of the velocity. We know that v0x is actually equal to x dot of 0, and if we substitute this part over here, we will obtain that c1 is actually equal to v0x. Consequently, x dot is equal to v0x. That is, the velocity in the x direction is always equal to the initial projection of the velocity onto the x-axis. Let's determine x now. From this equation, we obtain dx over dt is equal to v0x, or dx is equal to v0x dt. I will continue over here. From this equation, we obtain that x is actually an integral v0x dt plus some other constant c2. Since v0x is constant, we obtain that x is actually equal to v0x times time plus c2. Next, we need to determine the constant c2. We determine this constant from the initial condition. We know that x of 0 is actually equal to 0, since we start from this point and the coordinate system is located at this point. Consequently, we obtain x of 0 is equal to v0 times 0 plus c2, and this should be equal to 0. From this equation, we obtain that c2 is equal to 0. And finally, x of t is v0x times time. Here is x of t, and over here is x dot of t. We solved A and B problems for x and x dot. Since I want to keep this video tutorial as clear as possible, I had to erase the derivation that was over here, and consequently I only wrote the final result that's given over here. Next, we need to determine y dot and we need to determine y as functions of time. To do that, we need to scalarly multiply this equation with the unit vector j. The unit vector j is the unit vector of the y-axis. Let's do that. We have m times ay is equal to, let's see, what is the projection of mg onto the y-axis? Obviously, it is minus mg. We can cancel the mass and we obtain ay is equal to minus g. Ay is actually y 2 dots, and y 2 dots is equal to minus g. From this equation, we obtain that d over dt y dot is equal to minus g, or d y dot is equal to minus g dt. Next, let's integrate this equation. As the result, we obtain y dot is minus integral g dt plus some constant c3. Since g is constant, we can write y dot is minus g times t plus c3. Next, we need to determine the constant c3. We can determine this constant from this initial condition. Namely, we know that y dot of 0 is actually equal to v0y. By substituting this initial condition in this equation, we obtain that v0y is equal to minus g times 0 plus c3, and consequently we obtain that c3 is actually v 0, y. And finally, y dot is equal to minus gt plus v0y. Perfect. Next, we need to determine y as the function of time. To do that, we need to integrate this equation. From this equation, we obtain that dy over dt is equal to minus gt plus v0y, or dy is equal to, let's see, minus gt times dt plus v0y times dt. Let's integrate this equation. We obtain that y is equal to minus integral gt dt plus integral v0y dt. From this equation, actually, we are missing here the constant, right? C4. From this equation, we can actually obtain that y is equal to minus g, and integral of t dt is obviously t squared divided by 2, plus over here we can have v0y times t plus c4. Okay, perfect. Next, we need to determine the constant c4. Well, we determine this constant from the initial condition. We know that y of 0 is equal to 0, and by substituting this initial condition in this equation, we will obtain that actually c4 is equal to 0. And finally, y is given by this equation, minus gt squared over 2 plus v0y times t. Perfect. This is y. And over here we have y dot. Perfect. Again, since I want to keep this video tutorial as clear as possible, I erased the previous derivation that was shown over here, and over here are the final results. These four equations solve the problems A and B. Next, we need to solve the problem C. That is, we need to determine the shape of our trajectory, or in other words, we need to determine the function that describes this projectile's motion. Obviously, the projectile's motion will look like a parabolic function. However, we need to mathematically prove that. So how to do that? Well, from our first equation, we can express time. Time is equal to x over v0x. Then we can substitute this time in this equation. And let's do that. We will have y is equal to minus g over 2 t squared x squared divided by v0x squared plus v0y multiplying time. And time is x over v0x. Perfect. Let us a little bit better write this equation. We can write this equation as minus g over 2 v0x squared multiplying x squared plus v0y over v0x multiplying x. And here it is. This function mathematically describes the shape of the trajectory. We can obviously see that this is actually a parabola. This parabola looks like this. X, y, and here it is. Here's our parabola. Okay, we solved the problem C. Next, we need to solve the problem D. In the problem D, we need to determine this distance. How to determine this distance? Let's analyze this equation. We basically need to determine the zeros of this function. How many zeros this function actually have? Let's see. To find the zeros, we need to actually solve this equation. G over 2v0x squared times x squared plus v0y over v0x times x should be equal to 0. We can write this equation as follows. We can take x out. Let's see what else we can take out. We can take v0x out, obviously, and let's see what do we have over here. We have v0y from this term, right? Only that part. What else do we have? How about this term? We have minus g times x, and let's see what do we have over here. We have 2v0x. Let's double check this equation. Let's see. We took out x over v0x. Over here we have v0y. Then we have minus from this term g times x. Since we took x out, we don't have square over here, and everything should be divided by 2v0x. So what are the zeros of this function? Obviously the first zero is x is equal to 0. And that's precisely the point over here. How about the other zero? Well, the other zero is obtained for v0y minus g over 2 x over v0x is equal to 0. From this equation, we can actually determine x, and x gives us this distance d. Let's see. X is obviously, let's see, v0y multiplying what? Multiplying 2 multiplying v0x, and everything should be divided by g. Here's the distance. And x is actually the distance d on this graph over here. So this is equal to d. Now, before I conclude this video tutorial, I have to mention the following. Sometimes in physics problems, you will encounter the following problem formulation. Instead of v0x and v0y, your professor will give you probably velocity and the angle theta. And let's see what is now v0x if someone gives us, for example, velocity and theta. Obviously, v0x is v cosinus theta, and v0y is v sinus theta. Let's substitute these values in this equation. We obtain that the distance is actually equal to 2 times v cosinus theta times v sinus theta, and everything should be divided by g. Let's simplify this expression. We know that 2 cosinus theta times sinus theta is actually sinus 2 theta, and consequently this distance becomes v squared sinus 2 theta divided by g. And this is an alternative formula for the distance d, if v is given and theta is given. Okay, that would be all for today. I hope that you liked this video. If you like the videos I create, please press the like and subscribe buttons. Thanks a lot and have a nice day.